Okay, now we're going to look at factoring special cases. So the first one is factoring perfect square trinomials. So a little reminder about what we mean by a perfect square. Something like 25 is a perfect square because we can write it as an integer squared. So 25 is a perfect square. 16 is a perfect square because it's 4 squared. 36 is a perfect square because it is 6 squared. All right, etc. Okay, so perfect square trinomials take the form of something like x squared, where x can be any quantity. We're just using x as that stand-in, plus 2 times x times y plus y squared. Okay, so we have x squared and y squared. So two things that are squared is the first and last term, and then that middle term is twice the x times the y. And that is always going to factor into x plus y times x plus y, or in other words, x squared. If we have x squared, instead of having a plus 2xy, we have a minus 2xy, and then plus y squared. It factors into x minus y squared. So that is the rule that we can follow, or that's the format that we can follow. So let's apply that to an example. Let's take the trinomial 16a squared minus 4a, I'm sorry, let's back up. That should be 40ab plus 25b squared. So we want to kind of force it into looking like one of those formats that are just right above that. Okay, so let's take that 16a squared, and we want to write that as one quantity squared. So if we take the 16 and say, well, that's the perfect square of 4 squared, and then a is what we square to get a squared, and we take that quantity, that entire quantity, and square it, now we have just one single thing squared. So the 4a is like the x in the format above. Now let's go to the plus 25b squared. We can similarly write that as 5b, that whole quantity squared. Okay, so that's like the y squared up in the format in the box. All right, now we want to try to make that 40 match 2xy. Okay, so let's, we have the minus out in front, so there's going to be minus, we want to have a 2, and it is going to be, if it follows the format, times what would be the x, which is 4a, so 4a, and what would be the y, which is 5y, so that was like 5y. All right, so let's multiply all that together and see if that matches up with negative 40ab. Well, 2 times 4 is 8, and that's a negative 8 times 5, which gives us a negative 40. And let's see, I made one little misstep there. This y, you probably already noticed that. That should be a b. There you go. So we have negative 2 times 4 gives us the negative 8 times 5 gives us the negative 40, and then the a times b, that gets us back. Okay, so it follows the format. So that means that this is going to be one quantity squared, and that quantity that's squared is going to be x, which is 4a, and then it's a minus because that middle term is minus, and then it's going to be 5b because that's what's comparable to y in the format. So we end up with 4a minus 5b squared. Okay, let's look at another one. Okay, let's take 20 p squared plus 100 p q plus 125 q squared. Okay, whenever we factor, we want to think about if we can first factor out a greatest common factor. And in this case, if we look at this and we try to apply that perfect square trinomial format, it's not going to work. 20 is not a perfect square. 125 is not a perfect square. So let's start off with the greatest common factor. Well, there's a 5 that can go into each of those terms. So let's bring out a 5. Then we're going to be left with 40 p squared plus 20 pq plus 25q squared. Okay, now we look at the 4p squared and we realize we can write that as something squared. We can write that as 2p, that whole quantity squared, so that's like our x in the format. And the 25q squared we can write as the quantity 5q squared, and that's like the y squared. And then that middle term, if we rewrite that, we want to have a 2. And then the x part would be 2p, and the y part would be the 5q. Now let's just double check, make sure that gives us that 20pq. Well, 2 times 2 is 4, times 5 is 20, and then we have a p and a q, so that checks out. Okay, so we can now use that perfect square trinomial format. We want to remember that the 5 stays there. Okay, but it's going to be this quantity squared. And the first thing that we put in is the 2p. And we're going to add that because the middle term is positive. And the second term is 5q. And that's it. The next special case is the difference of 2 squares, and we can actually think of that as the difference of 2 perfect squares. Okay, all right, so again, like our perfect square trinomial, there's a special format. We can determine that our polynomial takes the form of x squared. All right, so something squared minus something else squared. Then that is always going to factor like this: x plus y times x minus y. Okay, every single time. All right, that's going to be the rule. Okay, so let's look at an example. Let's start off with 9y squared minus 16. Okay, well, we can write that as that 9 we can write as 3 squared, and so we can write that 9y squared as the quantity 3y, that whole thing squared, minus that 16 we can write as 4y. So that means that we can write that as, if we follow the pattern, we can write that as with 3y in the first position of those 2 linear factors, and in the second position we're going to have 4. And then what goes in between them, one of them is a plus and one of them is a minus. Okay, so all we really needed to do is determine, well, what are our perfect squares, and then plug those in according to the pattern. Let's look at another one. It'll be negative 4x squared plus 1. All right, so it doesn't look at it like a difference to start off with, but we can just reorder those terms and write the 1 first, and then it's a minus 4x squared. So we can write that 1 obviously as 1 squared, and we can make that 4x squared as the quantity 2x squared. So that means we can write that in factored form, where we put a 1 in the first position of those linear binomials, a 2x in the second position, and an addition and a subtraction. Okay, the third and last special case of factoring is if we have the sum and difference of cubes. So we are going to write down what the pattern is. If we have the sum of cubes, in other words, we have something like some quantity a cubed plus another quantity b cubed, that can be factored as the linear factor a plus b times the quadratic factor a squared minus ab plus b squared. And if we have the difference of cubes, so a cubed minus b cubed, all right, there's some just minor changes. It's going to be a minus b for the linear factor, and for the quadratic factor, it's a squared plus ab plus b squared. All right, so notice that the linear factor follows whatever the original cube sum or difference of cubes is. And then in the quadratic, it's the opposite of whatever it is in the, between the first squared term and multiplying the a and the b. And then for both of them, at the end, it's always plus whatever the b squared is. All right, let's look at an example. Okay, let's take 8y cubed minus 343. All right, so we want to write both those terms as something cubed. Well, 8 is 2 cubed, and then obviously we have y cubed. So we can write that as 2y, that whole thing cubed. Now, it might take a little bit of effort to figure out what 343 is cubed, but that's actually a 7. 7 cubed gets us back to 343. Now, once we have figured that out, our a is like the 2y, our b is like the 7. So we just follow the pattern, replacing a with 2y and replacing b with 7. Okay, so we have a difference here, so we're going to follow the second one there. Okay, so we're going to start off with a minus b, so 2y minus 7. All right, times a squared. So our a is 2y. So if we square that, we get 4y squared. And then we're going to have plus a times b, so plus 7 times 2y. So that gives us a 14y. And then a plus b squared. So plus 7 squared, so plus 49 squared.